Hello and most welcome to 2035 of the series. This will be a continuation of the read Iain McGilchrist's book, The Matter with Things, reading from chapter 34. And last, we ended with page 970. 970! 970. Last time we mentioned the flow and how fish in the flow need the resistance, the disturbances to stay in stasis still. Movement is a sine qua non for stillness. To be able to be still means that you have to take in its opposites. Resistance, disturbance, movement. It is the downward pull, the force of the flood, of the river that makes it possible to be in stasis. Fish that swim around or are in still water, they can make their own resistance, movement through gills and fins to produce stasis. So stillness, permanence is possible only through counterflow, counter movement. Those two forces come together, complementary. It's the coincidence of opposites. Coincidentia oppositorum, as mentioned earlier. Only when they help each other, we can have permanence, stillness, eternity, infinity, and so on. Bergson called this the indivisible continuity of change, which is precisely what constitutes true duration. True duration. And we mention in context with how tongue, how important the pre-state is, the proprioception. The proprioception do not take a preconceived reality into perspective. It's an openness without content. Only by this contentless state can it take in something other. It can let it come into existence to become real. This is how everything stems into reality. So in Hautang, I called it the intransitive mood, not taking an object, compared to the after effect of the transitive. The transitive take the object and now it's definitive. Now the superposition has fallen. Now the superposition has fallen. The fall of the superposition. These harmonies, these melodies, prosodies, and pitch are handled by the right hemisphere. And the potentially, on page 970, the potentially disjunctive element in rhythm, in music rhythm, is underwritten commonly by the left hemisphere. Very interesting. There is, a, so to speak, a hemisphere specifically inclined to notice disjunction, and that's the left hemisphere for the disjunctive understanding. Together, rhythm and melody makes the music flows, and that is a union of division and union. However, within this flow, rhythm is wholly transformed and becomes itself a unifying force. So there is a duality at the bottom. And you is that individuality is a phase, though a decisive and outstanding one, of a process having continuity. How beautiful. So you can see this is a wave where the hilltops, the very top, could be likened to disjunctive particles, but it is in reality a wave. This is exactly how it is depicted in quantum mechanics. And I will now continue on the third paragraph on page 970. The everyday business of describing the world uses a structure of symbols, language, and in particular, nouns. Nouns! That leads us to believe that there are non-unique things and that our representations of reality are the reality itself. The reality itself. By transcending language, one may see the world as unique wholes that themselves together constitute unique wholes at a higher level, and so on without limit. As William James remarked, the essence of life is its continuously changing character, but our concepts are all discontinuous and fixed. And the only mode of making them coincide with life is by arbitrarily supposing positions of arrest therein. Therein! Therein! With such arrests, our concepts may be made congruent. May be made congruent. But these concepts are not parts of reality, not real positions taken by it, but suppositions rather, notes taken by ourselves. And you can no more dip up the substance of reality with them than you can dip up water with a net. However, finely meshed, however, finely meshed, however, finely meshed. reality, like the river, is a flow which only seems to be composed of discrete drops when we try and fail comprehensively to catch it in the net of language. The bits that we do catch, the drops from the net, are an artifact of our process of investigation, of our investigation. Our investigation. No net, no drops. No net, no drops. Similarly, modern physics tells us that the entities that we discover when we probe the subatomic world are shaped by the process we use to investigate it. Famously so in the case of particles and waves. Of particles and waves. What seems to be fundamental is pattern and relationship, not the semi-distinct entities that are patterned and related. Think about the double slit experiment. Yet immediately, that we sense that our everyday language is inadequate. We sense that to what is meant, some differentiation is necessary for there to be anything out of which our relationship can be constituted. A relationship can be constituted. Constituted. And yet what is differentiated can never be separate. Because it is what it is only in relationship to everything else. This is the very essence of music. The very essence of music. Essence of music. Water and philosophy. Water and philosophy. A life without music would be a mistake. Life of any kind without water would be impossible. Schelling clearly intuited that water was a potent metaphor or symbol for the nature of reality, as indeed it is in Oriental philosophy, especially Taoism, which constantly recurs to the image of flowing water. In his treatise on the world soul, which Schelling wrote when he was only 23, he speaks of an equilibrium to life that must constantly be disturbed and re-established, re-established, re-established. Although he does not use this image, what comes to mind for me is the way in which the acrobat can balance on a tightrope only by virtue of its constant capacity for disequilibrium. If it were rigid, he would fall off. He would fall off. He would fall off. And in the same passage where Schelling makes this claim, he names oxygen and hydrogen. The elements of water as the two principles of life in the animal body. Acting as weights on the lever of life, the local disequilibrium of each, allowing for the maintenance of life itself at the scale of the organism as a whole. As a whole. Yet there are aspects of nature of water that even Schelling did not explore. John Herschel deduced in 1830 that the solid, liquid, and aeriform states of bodies are merely stages in a process of gradual transition from one extreme to the other. Which need not necessarily be separated by sudden or violent lines of demarcation. In other words, bodies have solid, liquid, and gaseous forms, palpable differentiations, but the forms are not necessarily abruptly distinct, but seamlessly continuous. Seamlessly continuous. Seamlessly continuous. Seamlessly continuous. One cannot tell one from the other because they go into each other. Seamlessly continuous. This insight, another example of relative discreteness within a relative continuum, came through studying water. Water, water. Nothing seems more intuitive than the nature of water. Yet water is a peculiar substance. A peculiar substance. Indeed, peculiar. Felix Franks, a physical chemist who devoted his life to studying the properties of water, concluded that of all known liquids, water is probably the most studied and least understood. Because of its hydrogen-bounded character, water is a liquid that flows at ambient temperatures, unlike almost any other substance. Not for nothing is the science of flow called hydrodynamics, writes Philip Ball in his fascinating exploration of water's nature. Water is not, of course, the only substance that forms a liquid, but very few do so for the conditions of temperature and pressure under which life is comfortably conducted. Comfortably conducted. And yet it has a high degree of internal structure brought about by the stickiness that can bind the H2O molecules into a dynamic, ever-changing labyrinth. Elaborating on the oddness of water, Paul writes, the hydrogen bond, then, is what sets water apart from other liquids. Other liquids. Other liquids. But it doesn't immediately explain why water is so odd. So odd. Why it is denser than ice. Why it is central to life. Life. Why it has such a capacity to absorb heat, and so forth, and so forth. Can we not think of water as being just like any other liquid, except more strongly bound? Not a bit of it. End of quote. It is very tough to make a good computer model of an H2O molecule. H2O molecule, he writes. In a phrase that invites one to ponder. To ponder. Surely, of all molecules involved in life, water, 2 hydrogen atoms and 1 oxygen, looks like one that should be rather easy to model. Rather easy to model. I am not so sure. Not so quick. But the difficulty arises, of course, because the way a hydrogen bond forms as 2 water molecules approach one another is so complex. Big surprise. Well done, Iain McGilchrist. The crucial difficulty is that hydrogen bonds form cooperatively, not independently. Not independently. This difference that makes computer modeling so difficult to express something intrinsic. Something intrinsic. I suggest to life itself. life depends on water because of its very peculiarity. Of its very peculiarity. Of its very peculiarity. As Philip Bowles explained, when it comes to water, the refined tools of the theory of simple liquids are often woefully inadequate. It becomes like chiseling with a screwdriver or banging in nails with a mallet. You can just about get the job done, but it doesn't always look very convincing or elegant. Or elegant. Water has, to use Abramovich's terminology, architectivity at one temperature as well as connectivity at another. Ball writes, a continuing mystery about dendritic snowflakes is why all six of the branches seem to be more or less identical. More or less identical with a dendritical snowflake. The dendritical snowflake. Why is it so? Why? Please tell me why. The theory of dendritic growth explains why the side branches will develop at certain angles, but it contains no guarantee that they will all appear at equivalent places on different branches, or will grow to the same dimensions. Yet snowflakes can present astonishing examples of coordination, as if each branch knows what the other is doing. As if each branch knows what the other is doing. Each branch knows what the other one is doing. I reported earlier something similar about the formation of deer antlers. But from this account of water, it would seem not to be a matter confined to the world of the living. The living! The single flake comes into being as a single gestalt. As a single gestalt. Unlike almost every other liquid, when water freezes, rather than contracting and becoming more dense, it expands and becomes less dense. If this were not the case, the world would be a very different place. A very different place indeed. If the ocean bottom waters were frozen, circulation could not take place, with the result that the northern countries would be much colder. Hot water cools very slowly since it must lose a lot of heat for its temperature to fall significantly. Significantly. So our hot water tanks and our baths stay hot for a long time. Water's large heat capacity means that warm ocean currents can carry a phenomenal amount of heat. Enormous amount of heat coming to Northern Europe. Thank God for that. Thank God for that. The Gulf Stream, which ultimately keeps Northern Europe warmer than Labrador at the same latitude. By carrying heat from tropical South America northwards across the Atlantic Ocean, bears with it every day twice as much heat as would be possible, that would be produced by burning all the coal mined globally in a year. One of the difficulties in modeling water is, according to Ball, precisely that the model starts from stasis, not from flow. A problem to which the reader will by now be alert. The fundamental difficulty with all these models, he writes, is that they try to force a static description on a changing scene. On a changing scene. And he goes on to elaborate. We do not have the technologies yet for tracking huge numbers of water molecules as they play out their tactics in the real liquid. In the real liquid. In the real liquid. In the real liquid, it all happens. In the all liquid, it all happens. Although it is now possible to take frame by frame snapshots of molecular processes over the incredible short timescales. The incredible short timescales. The incredible short timescales. Perhaps a few trillions of a second. Perhaps a few trillions of a second. During which they occur, it may never be feasible to monitor directly and simultaneously the environments and the trajectories of thousands of individual molecules in a complex and messy system like a liquid. messy, one might be forgiven for hearing there, if it were not for Ball's delight in its messiness. The left hemisphere of the Western scientist speaking, to which what we don't understand and cannot neatly predict, is of course a mess. A mess. And there we put a pause. So let's go for some quotes here. I go back all the way to 1971, I think. Or 1970. 1970. The last paragraph here, beginning from first sentence there. Reality, like the river, is a flow which only seems to be composed of discrete drops. When we try and fail comprehensively to catch it in the net of language, the bits that we do catch, the drops from the net, are an artifact of our process investigation. Of our process investigation. Of our process investigation. The way we choose to look at the world as disjunct rids us of complete understanding. In the case of flow, we are turning the flow into disjunct particles. Think of that we are only, in a way, we are only looking at the hilltops, and therefore we do not see that there is a wave lying underneath. A bigger explanation, a more complete explanation as it is. Only with that can we come to grasps, come to grips with reality. Sorry, sorry. Come to grips with reality. We need to see the whole picture, the two sides, the thing sticking up, the disjunct drops corresponding to particles, and the wave. It is a flow. And if we choose randomly, subjectively, to only adjust everything into particle, we will miss out on reality. Think about the double slit experiment. Particles will behave as a wave if we choose to send them one by one. One photon at a time will still make up the interference pattern. So the trows will be enlarged and the hills will be enlarged. Go to page 971. So it's all about relationships. Water is all about relationships. One could say it's one thing entirely and not made up or made of its parts, the molecules, the hydrogen, oxygen molecules. And yet what is differentiated can never be separate, because it is what it is only in relationship to everything else. This is the very essence of music, and it goes for reality as well. And remember the rhythm and the melody I mentioned earlier. They come together. The rhythm is the disjunct left hemisphere take on reality. The melody is the right hemisphere take on reality. Disunion and union together help to create union. And the new rhythm will be married with the melody and entrap music. There you got it. There you get it. They come together just as particle and wave in quantum mechanics. If we go to the next subparagraph or subtitle, Water and Philosophy, which is very close to water logic, whatever de Bono, the flow. And for instance, in Taoism is mentioned here, flow is the more fundamental side than the Democritian atom or stain. It's the flow that produces a stain or the particle or the atom. If you only look at the atom, we will be looking at the secondary creation, something that is derived and would be subjective, hazardous, arbitrary take on reality. Go to the second paragraph under the subtitle, Water and Philosophy. Water and Philosophy. This insight, another example of relative discreteness within a relative continuum, came from studying water. There we got to really understand how water is disjunct but still is one flowing formation at the very same time. Ball writes, it's the fourth paragraph or the little quote further down on the page, 372. And here is about the dendritic snowflakes and why almost always all of the branches seems to be more or less identical, the 6. There's no reason for that. but still they coordinate in an amazing fashion. Why is that? Well, they are not made as singular events, singular branches or stems. They come as a whole. And I think that's the important lesson to be taken here. If we look at the particles and derive the world from a stain or existence or something like that, we will miss out. We will not understand. We will not see the whole. We will not see the reason. It all comes as one gestalt, and so is water. Although theoretically it can be seen as separable molecules, it's the wholeness that works. Thanks to the enormous complexity of the hydrogen bonds. Without this miraculous property of water, life on Earth would be very hard, if to exist at all. Water would not be flowing if ice were heavier than water. Go to the bottom and stop all healthy flow of the planet. Everything would come to a full stop. And just as Ball said in page 973, second paragraph, it's about the modeling of water. If we try to force a static description on a changing scene, we will not understand. We will preemptively put understanding to the side and not let it enter. A pretty decisive move in the direction of non-understanding. Oh, non-understanding! We need to see the two-sidedness of reality. Without that, there can be very little understanding at all. The flow is what we understand. It is a bit like if we don't know how money flow into an account and how much, it will be very hard to know what the sum in the bank account is. This is a metaphor for how reality is. We cannot use disjunct parts to broader understanding. We need the wholeness, the gestalt, the whole take. And for that to come in, we should also be able more to relax the tension, the crookedness or the narrowness of the left hemisphere and open to the harmonious, synergistic, enforcing and balanced viewpoint of the right hemisphere. I say thank you very much. Have a very pleasant morning, day, or afternoon. Bye-bye for now.